Hi everyone, I hope you all will be fine. In today's video, we will learn the use of APDL mechanical launcher for solving finite element problems of linear geometry. In coming videos, we will also learn about solving non-linear geometry problems, but in today's video, our focus will be more towards linear geometry, and more specific, if I will say, then we will solve the problems containing spring constant. In today's video, we will solve a linear geometry problem having multiple nodes with multiple elements having same value of spring constant. So let's start solving, but wait. First we will understand the problem, then we will start solving it on APDL. So here in the example we have a spring assemble shown in figure 2.3. Here is our figure, which has 5 nodes: node 1, node 2, node 3, node 4 and node 5. uh, that means the number of elements in our problem will be 4. 1, 2, 3, 4. So let's read about the statement. In the question he asks us to find the global stiffness matrix, the displacements of node 2 to 4, the global nodal forces and the local element forces. Node 1 is fixed, while node 5 is given a fixed non-displacement delta is equal to 20 millimeter, and the value of spring constant is 200 kilonewton per meter. So let's start on APDL. So first I will search my mechanical APDL product launcher. Let's wait a second till it opens. Here it opens. In working directory, it's up to us where we want to install our file, store our file, and the job name we can enter any job name which we want, so that we can know what is the solution here. So here it is the option of run, which is hidden some to due to technical errors, so please ignore it. Maybe you might not have this. So let's run this file. Just a bit till the file is opening, since it is a little bit heavy software, so sometimes it takes time. Don't worry. Yeah, here we are. So first we will learn about the interface of APDL. So here preprocessor is all the key elements which we have to define, or the commands which we will apply in our element. In solution, we have the commands related to solving the problem, like we are define analysis type, we define loads, etc. And in general, post proc, when we solve the problem, here we can find out the results. But here, since we didn't run any problem, so we have a very few options here. But when we run a problem, then we have an additional options here. So let's start. So before starting anything, the first thing we should do before starting any problem, we should clear and start new, so that there is no previous values stored in our ANSYS, or we can say in our APDL. So let's start with defining. The first step we will do is to define the elements. So what we will do for defining elements, we will go to preprocessor. In preprocessor, element type, it is here we have a number of element types. We will go to add, then here you can see you have a number of options like link, beam, pipe, solid shell, constant, contact. But for spring we will use combination, and in combination we will further go to spring damper, because we have a spring problem. So we will select this, so our element is added. The next step is to define a real constant. Real constant means the value of spring constant. So what we will do, we will go to real constant, add add. Here it allows us to select the material type to which we want to give the value of spring constant. So since we have defined only one element, we will simply select it. Real constant number, it means what type of real constant would you can set its number according to your easiness or whatever you want to add. That it has no major effect on our calculations, so we will leave it as it is. So then we will add the spring constant. In our problem we have the spring constant value of 200 kilonewton per meter. So what we will do, we will put all the values in newton per meter, or you can say kilonewton per millimeter, because both have the same value. Like if you convert 200 kilonewton per meter into newton per millimeter, both will have the same unit. So we will put our values as it is. So but our spring constant value is 200, so we have doesn't need to change anything, because this is what we all need. So let what I do. Okay, so I have defined a real constant 1 with a spring constant value of 200 kilonewton per meter. The next step we will do the modeling. Like what we have nodes, we will define nodes, then we will draw our elements. For that we have to go to modeling. In modeling we will go to create. What we have to create, we have to create nodes. So we will go to nodes. So it asks us where we want to draw our nodes, because we are working in current file. So we will ask ANSYS to draw an active sheet. Here node number means the node number which you want to give to us. So we have 5 nodes, so we will first draw node 1, then 2, then 3, then 4, then 5. So first the node number is 1, and the location of x-axis is 0, also the location of y-axis is 0. Okay. Then since I have drawn only one node and I click OK, I have to open it again. I will tell you the other way where I don't need to open it again and again. So the second tab is 2, and the x-axis is, so since we have a spring constant, it doesn't matter what length we have, because whatever the value will be, it will change according to the length. So we will assume our spring constant length is 2 meter. So I put axis on. When I apply, see, it didn't close. When we see here, it is our node 1, here it is 2. Simply we will create nodes up to 5. Now for third node, I will give the name node number 3, and in x-axis I will give the direction change from 2 to 4. Then I will click apply. Similarly, I will create all the nodes. 6, apply. Then for node 5 we have a distance at 8 meter from the 0 origin. So last time I will click OK rather than apply, because if we click apply and then OK, then it will may duplicate the node. So I will click here OK. In the next step I will create elements from 1 to 2, 2 to 3, 4 to 5. For that I have to go to elements. Since we have created our nodes, now we will draw our elements. But first of all I have to check which element I have selected. So I will go to element attributes, then I will check my element type number, which is common 14, which is correct, and I need to see the which spring constant I have selected, which is 1, since we have defined only 1. So it's not a problem here for in this problem. But in next lectures we will define multiple real constant, and to see how we will assign them to our between nodes. So for drawing elements, I will go to the elements, then auto numbered, and then through nodes. Through nodes, first I have to select the 2 nodes between which I have to create an element. I will select OK. See, it's created the node. Similarly, for 2 and 3, if I click apply, it will not close this window. Similarly, I will create all the elements. Okay, now we will define our boundary conditions. Here we can see we have a fixed boundary condition at node 1. That means it will not have any deformation in x-axis, y-axis, or nor it has any rotation. But if we see in node 5, we have a displacement of 20 millimeter. That means we have to allow the deformation in x-axis, but in y-axis and z-axis it has a zero displacement. So let's define our boundary conditions. For boundary conditions, we have to go to the loads section. We will go to loads, then we will define loads, because it is something about loads, or we can say our displacements also comes under loads. So we will go to apply structural displacement, where we have to apply the displacement at node 1 and node 5 on. So I will select node 1. Okay, here I will define ux, uy, uz equal to 0, because we have no degree of freedom at node 1. Okay, for node 5 we have to give allow it in x-axis. So what will I do? I will restrict u, y and z. So I have restricted u, y, u, z and put its displacement value equal to 0 and simply click OK. In next step we will see if we have a load, then we will apply that load to that. But if we can see, there is a no load in our what we can see a problem, but yeah, we have a displacement value, non-displacement value, so we will give it at node 5. So what we will do, we will go to displacement nodes. Yeah, okay, but sorry, here because I have to restrict it, so I restricted u, y and z. It will not move in u, y and z, but since it has a value of 20 millimeter in x-axis, so I will allow. So what I am doing, I am selecting ux and then giving the value displacement 20. So basically I am asking or telling my ANSYS that we have a displacement of 20 millimeter in x-axis at node 5. Okay, then what will we have defined our all the needs which we have to define, like we have to define our nodes, our elements, our boundary conditions, etc. Now we have to simply solve the problem. For that we go to our solution, then we will go to analysis type, new analysis, and select static. Okay, then we will simply solve our problem. So go to solve, go to current ls. Okay, so solution is done. So now we will go into general post proc to see our results. See, as I told you in the beginning of the video, when we will solve the problem, we have a lot of options here. So first I will go to list results. I will see the nodal displacement first. For that I will go to nodal solution, degree of freedom solution, degree of freedom in x component. Here we have a value of degree of freedom on in x-axis on each node. We have a displacement of 0 at one node, a displacement of 5 in second node, and so on. Similarly, we can see our displacements in y component also. In y component we have a 0 displacement because nothing is happening in that direction. So and similarly, if we want to plot results, and we have other various options which we will learn when we have some new problems, or we can say difficult problems, we will learn about them in our upcoming videos. Thank you.